Okay, so I think I'm gonna make a video about this because this way I can both iron out the idea and maybe even get some feedback what people think about this idea because I'm gonna start building it, so might as well. If there's some flaws in my thinking, then it's a good time before I do the work. And I'm calling this an I, IPFS Hot Node because it is the most appropriate name I could come up with. So what does this do, or what is the current challenge that we have with 3Speak? Um, I haven't talked about this on this channel yet. If you're watching this on Hive, of course you know about this. But if you're watching it on YouTube, then you don't know. But one of the things that I've been doing for maybe five, maybe even more months has been working with the 3Speak team, and I've been rebuilding a lot of their infra, rebuilding new encoders, rebuilding management tools, and even working with Quesolink and Eddie on a new front end for 3Speak. So as part of all this rebuilding that we've been doing, this upgrading, one of the things that we've had to do and we've had to really work on hard is the IPFS system. Uh, it is IPFS is one of those things that can be amazing, and it is amazing. It has some really awesome things about it that I love. But at the same time, it has its downsides, and I've talked about this on my blog at length because there's been days where I just love it and I think it's amazing, and I can't believe this technology is out there. And some days where I just hate it because of its quirks, because it's not without its challenges. So what am I trying to solve here? So right now in the 3Speak system, of course, it's going to be a lot more complex than this. We have a super node. Like this is a big server that hosts all the videos, and it's like teras and teras and teras. So I'm going to call this guy the super node, and we are using this guy for absolutely everything. So in this server, we are storing images, we are storing videos, and of the images are usually for obviously for the thumbnails of the videos, but we're storing the videos. But these videos are particularly heavy because they use something called an HLS structure. So an HLS structure is, I think it was Apple came up with it a long time ago. And what it does is basically grabs a video and it separates it into segments. And so we are encoding the videos in different qualities and then splitting them up into segments. So what happens here is that when the supernode is storing it, it has to store all these pins, and I guess we can talk about IPFS, but we'll do that in another video because IPFS is a whole nother monster. This is not going to be so detailed about IPFS, but all these pins have to be stored in the repo of the super server. So if you ever see an HLS structure, you're going to see normally a folder that has a manifest, and then inside that folder you'll have different qualities for 80, for example, 720, 1080, and then inside each folder you'll have segments. So of course that means if the video is very long, it's going to be a lot of segments. But the Supernode is amazing for long-term storage, and it is so not only because it has a lot of storage itself, because it does, but more because it has redundancies. So it has a RAID system, so if a hard drive fails, there's a way to recover it, etc., etc. But this also means that it can be slow. So right now, when a user requests a video, so I'm gonna pretend this is the user requests a video to it will send that request to one of the front ends, and there's a few of them. So let's pretend this is the the new one right now. So I'm just gonna put 3Speak, but let's pretend it's the new one, right? Anyways, so what this front end does, it goes after a player. If it's a new one, it's using a Snappy Player, one that I built, um, and this player, we're gonna call it here. It goes to a player, and then this player consults in a database, which I'm gonna put over here, that has all the CIDs. Called it's a Mongo database, consults with the database what is it that it should be looking for, and once it gets that info, so it asks, and once it gets that info, then this database is going to return a CID. So this database is going to give it back the CID, the unique identifier for the video. So the player says, hey, give me the video, and then the database responds. And then this player goes then to the supernode and says, give me the video. So request for the video. Well, actually no, that's the CID because it's really requesting for a CID. And so then the supernode has to look in this gigantic storage for that video, and then it will give it back to the player. And then once that happens, so let's say here HLS responding with HLS, and so once that happens, once it gives it back to the player, then the player then feeds it back to the 3Speak interface, and then of course here's the user finally sees it. So all that has to happen. So the bottleneck is without a doubt here in the supernode, because in this process here, sometimes when the repo is really big, or there's a lot of people requesting videos, it can get very, very slow, and it can be frustrating. So the idea that I'm thinking about making a IPFS Hot Node is very much aligned with how Hive works. And the Hive blockchain, you basically have 7 days of, let's call it, high activity. Obviously, a post that you make on Hive will live on Hive forever, and that's what's beautiful about it. But because it only collects, Eddie's talking to me there, because it only collects votes for 7 days, then most people don't watch videos that are older. Does it happen? Of course, but it's usually the first 3 or 4 days that you watch a video, and then after that it kind of just dwindles away. So what I'm thinking about doing is adding another node, hence the name, a supernode. Not a supernode, I'm sorry, a hot node. So that hot node would exist not instead of the supernode, but alongside so I'm going to call this the hot node alongside the supernode. And of course it doesn't have to be that big, and that's the whole point. It's going to also store images and videos, but it's only going to store images and videos for 7 days. So this is a temporary storage. So it's for 7 days, that's it. And after that, it's gonna be deleted. So what that means is basically, now imagine this whole thing, and I can go ahead and change it, but imagine, let's move this for now. That I use a hot node now and not the supernode for all this stuff. So now it's gonna go here. Because the repo is gonna be small, this is gonna take way less for it to happen. And I apologize for the background noise, but I live in a farm with people doing stuff about, so it is what it is. But you would say, okay, so what happens after the 7 days? And here's kind of when it gets kind of fun, at least for me, is I am thinking about creating a new service. So obviously, if I make this supernode, this hot node, then I have to make sure that I have a way to retain those videos, because you don't want to delete them forever. So how do you do that? How do you make it to where these videos survive the 7 days? Well, then there would be a new service that I'm gonna call cold storage for now. Maybe there'll be a better name later, that will live alongside this hot node. And this new service would be asking the hot node, hey, what do you got? Do you have something that you need to store in the supernode? Do you have something that needs to be migrated? So it's really like a migration service, and so this guy would then slowly, and that's the beauty of it, would be moving things to cold storage. Let's call it cold storage. Now, um, so anyways, the hot node then would work as maybe cache does in a browser, allowing for videos that are constantly being played. Uh, Also possibly, if I make it smart, it could also be like that. But the newer videos that are constantly being played to load fast, and then this means, of course, that if you want a video that's old, it doesn't matter because it's still stored in the supernode. So in a case scenario, for example, that I request an old video, I go to the front end right here, and then I say, okay, player, give me a video, and then the video checks right here in the MongoDB. Okay, this is the CID, tells the player, and then the player uses first the gateway of the hot node, but it's not on the hot node. So then it goes like, oh wait, then let me try the other gateway, which will be this guy, and then it'll find it, and then it'll display it. So what we are building is basically something that will, without changing much of the pieces of 3Speak, it would make 3Speak work so much better. Another really cool thing about this is that we don't have to make the hot node be that powerful. It has to be, obviously it has to be fast in the hard drives, but it doesn't have to have crazy processing, and it doesn't have to have a lot of RAM, funny enough, because it's just storing things in a temporary basis. And it also, well, actually it requires to have a really fast internet connection. But it also doesn't require GPUs or anything like that, because all it's doing is providing servicing CIDs. That's all it's doing. And so we can set up a RAID right here, a zero RAID, so it's all speed. We don't care about backups because it doesn't matter. But what it also allows us to do, and this is what I'm getting pretty crazy with this design, is allows me to set up more hot nodes later. So this is what's really, really exciting to me. In the current 3Speak system, we have a bunch of encoders. I'm gonna draw them like little circles, right? These are the guys that are making people upload raw videos, and they make them HLS structures and encode them and stuff so that people can play them. And these are run by the community. So I have one, Eddie has one, Thor has one. There's a bunch of us on Hive that have one. And right now they are all storing things in the supernode. So when they get done working, they get done working and they're like, okay, they finished the job. They place all their videos in here. So like after they're working, they all go here. And that's been working fine, at least at the amount of users that we have currently. But I think this new system opens up the door for something really amazing, which is what if the encoders, which we can have as many as we need, ask where they should upload the videos. So I'm gonna call this like a traffic director. So maybe what I do is I make a new service, and this one can live and it's gonna be a tiny service. Can live anywhere really. I'm gonna call it. Well, you get the point. And so when the encoders are done with their work, they ask the traffic director, hey, where do I upload? Right? And then this guy returns to them the node. Tells them, hey, upload to this node. So what does that mean? That I can set up as many hot nodes as I want. So in this new service, I could have a list of all the hot nodes that I need and eventually just grow it as need be. So let's say tomorrow we have, I don't know, like all of a sudden traffic triples, and it gets crazy. Then instead of me having to worry too much about, this node getting killed, I can literally just spin up another one of these pretty easily within a few hours of work, and then add the domain of the new node to the traffic director, which will be doing it as a round robin initially, but eventually it could be done by assessing storage capacities or speed or what have you. And then this guy then, after returning the information to the encoders, then the encoders would know, okay, so, oh yeah, that's where you want me to do it? Okay, and then they'll go ahead and put it over there. Or in another hot node. So obviously this means there's quite a few things to build still. but I think the idea is pretty cool. I would have to build the migrator, which I put here as a cold storage, but that's not really difficult to do. Um, the information for this migration wouldn't. Not, I put it here like it's asking from the hot node, but it wouldn't be asking from there. It would be asking from MongoDB. Single source of truth is kind of important on system designs. But then I also need to build a traffic director, and then I would need to upgrade the encoders. So all this work I've given myself. So the encoders would have to have a new thing that they have to do, which is to ask the new traffic director, where do I upload? And the new hot node is going to have another service running, which is going to the only two things are going to be running on it: the IPFS daemon and the migration service. And boom, that is it. With this, we can scale, and it also means that eventually, if we need another supernode, all I have to do is point the cold storage to another massive storage unit. So and that's the beauty about doing it with IPFS. So you don't have to be migrating stuff by transferring it, one by one, because these are pins. You can literally spin out a list of the pins you need to migrate, and boom, you're done. So, yeah. Anyways, I think that's going to be it for this design idea video. The video might have gone too long. But if you ever played with IPFS, if you're in Hive and you're watching this and you wonder all the stuff that we've been doing and all this craziness, and you want to ask me questions, go ahead. I find this fascinating. We already done so much. So many things have changed. And every time I take a step back and I look at what we've built, I just feel overwhelmed. I'm like, yeah, we did that? That's crazy. But anyways, I'm really, really proud of it. And yeah, so I'll catch you guys on another video. That's it. That's it for me. Too much rambling.